A skier is being pulled by a tow rope up a hill at constant speed. Draw a picture of the skier. Now draw a free body diagram of all the forces acting on the skier. Be sure to indicate the direction and magnitude of the forces with your arrows. Discuss each force and how they compare to each other in magnitude and direction.
Alright, so to represent the question, which is a skier being pulled up a hill, we drew obviously the skier on his skis being pulled up the hill by a snowmobile with a rope, because obviously we don't have any numbers or any figures to show it, so we just used our imagination and added a snowmobile and a skier being pulled up at constant velocity.
This is going to be our free body diagram for our picture. And so this black dot here represents our skier, and all these arrows represent the forces we have acting upon him. So to start off, we have gravity. Gravity always points down towards the center of the earth. So here he's going to be pointing down gravity. So the magnitude of our arrow for gravity is pretty big. We're going to call that about 9.8 meters per second squared. And then we have three other forces acting upon him. That's our force of tension, which is going to be being pulled by our snowmobile. Our force of friction, which is going to be pulling opposite to the tension with the contact of his skis in the snow, creating the friction. And our normal force pointing this direction, which is perpendicular to the hill he is going up. So theoretically and mathematically, we're going to have all of these arrows eventually cancel out. So being that these are vectors, you have an x and a y component for each vector basically, and the height of those are going to cancel out the height of the gravity and for the height of the frictional force, along with the x vectors will eventually cancel each other out and to create a net force of 0.
And now I'm going to explain why the net force is actually 0. And this relates back to Newton's second law, which states that the acceleration of the skier is dependent upon both the net force and the mass of the object. So you can see here F equals ma, so the net force is equal to the mass times acceleration. As stated in the problem, the acceleration is 0 due to the fact that the skier is moving at a constant velocity. And this causes our total net force to equal 0. Because as you can see, if acceleration equals 0, anything times 0 is going to be 0. So the sum of all of these vectors that were just shown in the free body diagram are actually going to cancel out, and it's going to be 0 as a whole.